One area of puzzlement that sometimes shows up is how you explore relationships between variables, especially when they're different kinds of variables. What's allowed when you're doing whatever. What I mean is that quantitative variables versus categorical variables and how you're going from one to the other. There's a nice summary of that material on page 72. That's actually module 6. It's a one-page summary of modules 4 and 5. So I would invite you to look at that for a very succinct summary. What I'm going to try to do is kind of maybe throw some examples out and try to help you sort of use, quote, common statistical sense in order to figure out what's going on. So yeah, two-way tables is part of what's done in this area of the book. Like a two-way table where you've got, maybe uh, the weight of the baby and the health of the mother, right? And you got rows and columns, and you got to, figure out row probability versus uh, column probability, that kind of thing. Or maybe just what percentage of the whole of these births were to, how many were there light babies and unhealthy mothers, right? That's percentage versus the whole. Those are the kinds of questions, but look at what's going on here, right? One variable is birth weight of the mother or is health of the mother. That's not a numerical scale. That's like healthy, not healthy. Or maybe you put not healthy, very healthy, and moderately healthy, right? This is a kind of subjective judgment, and it's described by words. So health of the mother has, let's say, 3 values: low, medium, high. And then weight of the baby, yes, you could weigh that in numbers, and we'll explore that next. But let's just call that underweight, healthy weight, and overweight, right? 3 variables of that. So there's 9 possibilities. Now, you are gathering numbers, even though this is categorical versus categorical data. You're gathering the count of how many of each kind, right? There's 9 kinds because there's 3 kinds of babies and 3 kinds of moms. The count of these variables is what you're gathering. And that, of course, is numerical, but that doesn't have anything to do with that being classified as a C to C case, categorical to categorical. Now let's compare that to some other modification. What if it was categorical to quantitative, right? What if you had, right, the weights, the health of the mothers, low, high, low, medium, and high, and you actually had the numerical value of the weight of each of their babies, right? So for the unhealthy mothers, the low health mothers, you'd have all the data of those births. And then for the moderately healthy, you'd have all the data of those births. And for the very healthy, you'd have all the data for those births, right? You'd be wanting to compare categorical to quantitative, right? Categorical to quantitative data. So you have to figure out what would be the best way to present that quantitative data and also to present it simultaneously. Generally, that's going to be a box plot. Generally, you're going to have a box plot, the stem and the whisker for each kind. So that would come out. Let me go back here and just put, number to remind us of the two-way table and just the counts in there. And I'll also label it C to C. And I'll just put the scribbles here to remind you that there are words here. Well, Here, what we've got in the second case I'm discussing is categorical to quantitative. For this kind of mom, right, we have a distribution of weights of the babies. Generally, what we do is we compare stem and whisker plots. Sorry, box plots, my mistake, right? So you have the box plot representing the weights of all the babies of underweight, under healthy moms, then the medium healthy moms. Maybe that's going to be something like this. I'm totally making up the data, but I'm just letting you know. This is the kind of thing that, maybe you're expecting. And then there's very healthy moms. Maybe that's something like this. I have no idea what the real data would be like in real world, but at least what you do here is you have the ability to compare the data, right? That's always the point. How do you compare the data, right? Remember, we have our totals for rows and columns over here, and categorical to categorical. And there's the full N of every single subject being measured. We lost some data on how many. Maybe under each of these categories of women, we would say how many there were in the study, and then we would just have the box plots showing us the median and, essentially how widely spread those weights were. As you can see from my data, what I'm assuming is that the unhealthy mothers are much more likely to have either underweight or overweight babies. The medium healthy mothers have generally slightly heavier babies, but there's less range, less very overweight and very few very underweight babies. And for the very healthy mothers, there's very little range away from that sort of ideal weight for a baby, because very healthy mothers, I'm assuming very healthy babies don't have much variation. Again, I made the data up essentially just to go, hey, what if we had the category of moms and then we actually had numbers for the weights of those babies, C to Q. Now, if we had a Q to Q, right, Q to Q would be number versus number. Generally, we want to make absolutely sure that that's paired data. In other words, there's one origin for 2 points of data. Usually the classic is something like height and weight. We each of us have a height and a weight. Those are both numbers, right? Twice the height means twice as tall. Twice the weight means twice as heavy, right? It's not like first, second, third place. In a race, there's actually, meaning and ratio to the numbers. So they're beautiful numbers, and each person generates 2. That's when you want to do a scatter plot. It's very, very simple when you just, boom. We want to do a scatter plot because we've got all numbers on one axis and all numbers on the other axis. To continue this, because each child is associated with its mother, we could, I don't think we'd have a numerical value for health of the mother unless we had some interesting scale to create a number out of many factors. I'm sure that's done in some studies, but let's just imagine we're doing mother's weight versus baby's weight, just to check and see if there's any relationship, right? That's fairly well paired data, right? Each element, each single thing, and that's a baby and a baby's weight at birth and its mother's weight at birth, right? Together, right? That one scenario, a birth, generates a weight for the mom, a weight for the baby. So you can put your mother's weights along the x-axis, put your child's weights on the y-axis, and you have a bunch of scattered data. I have no idea how the genetics and or health of the real world works, but every Q to Q is essentially representable by dots. And I'm sorry, those are coming out, not dots. I don't have a good sprinkling tool. Pretend those are dots, sorry, right? I really have no idea, so I'm not gonna try to build any pattern. This is Q, right? You've got the values that go up and Q, right? I'll even just do it that way, Q to Q. Numbers versus numbers. You're used to graphing like that from, all of your algebra classes. And that's it. We don't really deal with Q to C because that's taking like a numerical value and then measuring something that goes to categories. That's pretty rare. You might get into a little bit of that in Stats 2 if that's on your program, but I'm going to ask you not to worry about it. So just core idea, 2 categories. Well, categories don't go in any particular order, maybe alphabetical, but that's not a real order. So all you can do is just create the table. So categorical to categorical comparisons, create the table, and the numbers is just going to be how many of each, kind of like a histogram, right? You had quantitative data, but you only had the number of each in each category, in each separate interval on the quantitative data. So category to category, just count them, table. Quantitative to quantitative, right? That's sort of a continuum of values that they can have left and right versus up and down, not just you're a smoker, you're a non-smoker, you're right. So graph it. And just be aware, you're not going to graph like the scores of kids on a test in your morning class versus the scores of your kids on a test in the afternoon class. You can't do a scatter plot on that because the numbers aren't associated with each other, right? What are you going to do? Put them in alphabetical order? What are you going to do if they're different sizes? There's no connection between the data. So think of that scenario where I said one individual generates the 2 numbers, height, weight, or one event generates the 2 numbers, birth weight of the baby and weight of the mother during the birth. So there's got to be that connection between the data being generated when it's Q to Q. And then C to Q, I just picked an example where it seemed like scatter plots would be the easiest way to compare the 3 scenarios. You could do little miniature histograms for each of the 3 scenarios. You could do side-by-side stem and leaf plots for each of the 3 scenarios. So it's just a matter of the categories will create identical kinds of data display. Could even be pie charts for each, right? Let's see, dictatorships, democracies, and monarchies are my 3 categories. And I have a pie chart that shows what percentage of their budgets are dedicated to military, to health, to whatever, right? You'd have 3 pie charts for the 3 categories. So your graphical display can always vary, but it's going to be separate for every category. You'll have the same kind of display, but it will look different based on the quantitative data you picked up. So I hope that helps you kind of straighten out these 3. And I hope I've presented it in a way that kind of feels like it's more like common sense than just looking at page 72 and trying to memorize it, trying to force it into your mind. In some way, it's kind of natural. Again, category, all you're doing is counting how many in each. Category to quantitative means you have numerical data for each of the different, very distinct flavors of the other variable. And so that quantitative data needs its own separate display for each of the categories. And quantitative to quantitative, where you have each element generating 2 numbers at once, or even, pre-test, post-test, but it's the same kid, got that pre-test score, that got that post-test score, right? Where you've got the connected data, the paired data, write the pair as a coordinate, right? Coordinate pair, graph it, and then you've got your scatter plot. There you go. I hope you find it useful and that it helps you get more statistically powerful and pass that in.